Okay, so next we'll be moving to the law of indices. So indices, there are many, rules involved in solving indices questions. So since like in O levels and your future examinations, you'll be like manipulating different kinds of equations, which involves different laws. So the first part we'll be doing is the same base indices laws. So here we have two real numbers, a to the power of n and a to the power of m. They're both real, so yeah. And this a is the same for both. So if this is 1, this is 1, because they have the same integer. So over here we have this first law, which is a to the power of n times a to the power of m will give you a to the power of n plus m. And here is a to the power of n divided by a to the power of m is a to the power of n minus m. Now, here's the example for it. So if a is 2 and n is 3 and m is 2, we can just expand it like this. So 2 to the power of 3 and 2 to the power of 2. So we use this expression, this formula, and we plug it into here to find 2 to the power of 5. Now you can just plug it into your calculator and you'll get the answer. Similarly for this, use this formula over here, and yeah, you find it. Now, the reason why this works, this formula works, is like when you expand it, for example, you multiply it over here by n times, and then we multiply here by m times. As you can see, you're multiplying this entire thing by n plus m times. Therefore, this is the expression. And for this one, we're already here. Since it's a times this n times, you're dividing it by a times a m times. Now you can see that these will cancel out all the way until you get n minus m. Because let's say if n is greater than m, then there'll be a few numbers there'll be some that aren't cancel out at the top. So that will be n minus m, which will give you this. And if n is smaller than m, then there'll be a few numbers at the bottom, which will give you a negative number in that case. So here, there are more laws which are easy to identify and use. So here are the expressions. If it's a to the power of n bracketed and then there's an m outside, you multiply it, because it's like you're taking a power to another power, so you multiply the powers together. Now, anything to the power of 0 will always give you 1, no matter what number a is. And this is the inverse law. Actually, yeah, like in this case, since this negative will mean that it's at the bottom, like that. Like it's like a reciprocal function, So yeah, this is how I guess it works. Now for these two, it's just, like your square bases, yeah. I think the proofs will be at the back later. And for this is different base laws where the a and b are different numbers. So you can expand and simplify these, and it gives you these. So a times b will give you a to the power of n times b to the power of n. And then a to the power of n divided by b to the power of n, you can express it as this form. Because both have the same powers, you can just put it out over here. Over here, it's basically the reciprocal one, where as you can see, there's a negative sign here. So you can actually just swap these two around and get rid of the negative sign. So here's a simple question for you to try out. As you remember, this thing uses the same formula, a to the power of n times a to the power of m, it just gives you this, because both have a similar basis. So you can solve it that way, and you get this. Now the next question, you simplify this expression. So as you can see, there's an x squared at the top and an x cubed at the bottom. So the first thing you want to do is try and cancel it out. So if you remember, this is just x squared divided by x cubed. So you use this formula an divided by am, which will give you an minus m. So this will give you x to the power of -1. And remember, that's just 1 over x. So you can basically write this expression as y over x to the power of half. And then from there, you can just express it like this, or you can also express it in this form. Both works because it's basically the square root. Oh, it's here. Yeah, you use this formula. Actually, you can just get like this. It's faster.